7 steps of chapter 5. And in this problem, we are given roughly this shape and a force on it. We're given the weight of the thin bar, which from that we can get mass. And then we're also given that it's released from rest. So from that we can assume that the angular velocity is 0. And we're given the interior angle here, theta. And we're also given that there's going to be no friction in the problem. And with this, we are tasked to find the angular acceleration and the reaction forces at A and B. So with this, we're starting with step 1, draw a free body diagram. And we should have 4 forces here. The reaction at B, A, and then the force given in the problem right here, and then also the weight acting through the center of gravity. And then also in step 1, we have to set the coordinate system, which we just chose as standard Cartesian. Step 3, we have to sum all the forces as vectors. So we gave the reaction force at X at B as only in the X direction, basically positive towards the right, so EX I have. And then weight was in the negative G direction. Reaction force at A was in the positive Y direction, and then the force was in the positive I direction. And then step 4, we're to set the acceleration into vector form. And we did that since it's at an angle and we know for theta, we set it equal to AG sine of theta in the X direction, and then AG cosine of theta in the Y direction. And then from this we go to step 5, which is plug the acceleration and then all the forces in vector forms into the sum of the forces equals mass times acceleration. And from that you can see we get that, and we get 2 equations to start with. One for the reaction force at B and one for the reaction force at A. And then in step 6, we plug this into the new equation that we got in chapter 5. And then we can take the moments about G with this to give us our equation. And this will give us a third equation, which we can make equal to alpha. And then the last step is step 7. And with this, we had 3 equations, but we had 4 unknowns that we needed to solve for. So we had to find another equation. And with this, we used the acceleration equation from chapter 2, using the acceleration at point A as our other point. And from this, we got a 4th equation for the acceleration in the center of gravity. And then from this, we can plug equation number 4 into equations 1 and 2. And then we can plug the equations at 1 and 2 into equation 3. And then solve for alpha. So that will give us alpha. And we can then plug our value for alpha into equation 4. And that'll help us find the acceleration at the center of gravity. And then we can plug in the acceleration at the center of gravity into 1 and 2, and that will help us find the reaction forces.